Hello, everyone. Thank you for joining. I'm going to give it about 1 more minute before we kick this webinar off, just so we can give everybody a little bit of time to join. Okay, hello everyone. Thank you for joining. It looks like people are still trickling in, but we're going to go ahead and kick this one off. This webinar does have quite a bit of context, and so I want to make sure that we give our presenter enough time to get everything presented. So thank you everybody for joining our second installment of our monthly webinar series. Today we'll be investigating OneNote malware with Team Axon. Today we have presenting Jonathan Kanashvili he is a threat hunting expert on Team Axon. Sorry, apologies. My name is Ben Martinez. I am customer success engineer. Couple of housekeeping items. As we're going throughout this presentation, feel free to drop any questions in the chat. I will be monitoring the chat as we go along. If there's any relevant questions that need to be answered for the entire group, I will go ahead and kind of pause the presentation so we can get those answered. If not, we will answer them at the end of the session. We will also have about 5 minutes at the end of the session if you have any other questions remaining. So at any point, feel free to ask questions. Engagement is highly encouraged, so feel free to drop those in the chat and enjoy. Jonathan, go ahead and take it away.
Thank you so much, Ben. Thanks for the lovely introduction. So yeah, it's great to be here with you guys. As Ben mentioned, I'm Jonathan. I'm here with Team Axon for about a year now at Hunters. And I suggest we will kick it off with me presenting the screen. So let's go. So as Ben mentioned, today we'll speak about investigating a really huge trend that we saw on the last few months, which is the OneNote malware. It will be a really interesting workshop. We will do a lot of things together. So it's also be an interactive workshop. So let's get started. So the agenda for today will start with our North Star for this whole presentation, which is our threat hunting methodology, which will be based on the process that we will doing in this workshop. Then we will start to take a look on the threat overview, learning about the threat, what is this threat, why it even started now, like why this trend started now, which is kind of interesting question, right? Then we will dive into some intelligence trends that we saw in the wild, some numbers about the number of campaigns, specific threat groups, and the things that we can understand from that. Then we'll have a threat deep dive. So we will deep dive into the OneNote structure, understand how it works, and also see a video about how to properly analyzing it and recap some forensic artifacts that we will use in order to perform threat hunting. And in the threat hunting section, we will use the notebook feature together and start executing queries, analyzing them, and review the results. And we will wrap it up with remediation and prevention practices. So as you see, we have tons of things to cover. So I suggest we will get started. So the North Star, the threat hunting methodology for today, we'll start with theoretical knowledge. We will gain the relevant theoretical knowledge that we want to gain in order to proceed further in the hunting. We will understand how the threat is working, what is this threat, and then we'll use it to apply it to research. We start to collect the relevant artifacts that we will need in order to perform the threat hunting. After having those two, we will have enough information to start ideate threat hunting thesis. So start gathering in our mind threat hunting questions, threat hunting hypotheses that we will do in parallel with developing threat hunting queries in order to detect the threats. Obviously, the fun will be the hunting time, taking all of those results and analyzing them, and also to see how we can sometimes taking those results into detection engineering and implement analytics inside the platform. We will also see a correlated story at the end of the presentation. So we will do that as well. So all of those will be the overview of this presentation, will be based on those during the presentation. So now I want us to start with the threat overview. And the first thing when we're speaking about OneNote as an attack vector is actually the question is why now? Why it started now? And the question for it is not that complicated. It's actually related to what we'll have to call a post-macro world. So basically, Office macros was the most prevalent threat vector in the last years. Threat actors loved and still loved it as an initial access method. And what happened is that in the last month, Microsoft started to make a lot of announcement about their motivation to start blocking macros in default configuration, basically eliminating execution of external macros from external sources. It's still not 100% in default configuration, but they're making progress in order to do so. And as a response, threat actors started to be prepared for the post-macro world, and with that, they are delivering payloads, with different methods, such as isofile, LNKs, and now, as you probably understood, OneNote, which is the trend that we are going to speak in this session. So the other side of OneNote, and I want to do a really quick recap about OneNote in general. So basically, OneNote is a digital note application that is part of the Microsoft Office suite, which means that it comes installed when you're installing Office in your machine. Basically, it allows the user to organize notes and take notes with what they call a notebook. And what happened in the last month, actually in the last couple of months, we saw a really huge rise in the utilization of Microsoft documents, Microsoft OneNote documents, to transmit malwares over the mail. As I said, threat actors started to switch the traditional macro approach and move to embedded objects inside OneNote, which we'll go into it in a few minutes. And these campaigns, affected hundreds, if not thousands of organizations worldwide. We saw some examples in Axon, and we also updated in the intelligence community. This thing is huge, and we as an industry need to share knowledge and get prepared for it. So this is exactly why we're performing this webinar. So now I want to move on to OneNote from the attacker perspective, from the OffSec perspective. So why attackers love to use it and what the advantages of using OneNote compared to Office macros. And the first one will be, it basically not affected by the protected VU. So protected VU is basically a default, really old feature that Microsoft developed in macro, in Office, in order to avoid user to execute macros. Basically, having a mandatory requirements to enable editing before be able to interact with the document. This configuration is not available in OneNote, and it makes it really dangerous in terms of executing the payloads inside it. The next thing is the ability of actors to embed objects, what we call an embedded object, which is in simple words, the ability to insert external files inside the OneNote notebooks or OneNote sections. So those files basically can be HTA files, LMK file, executables, any files that the user can just open and execute it when he double-clicked on. And this is really huge feature that OneNote enable and allow, while Office macros aren't, basically. So we should keep it in mind, and we will dive into it in the deep dive section and understand how we can identify it in multiple ways. The next thing is the ability to allow spoof extensions with a method that we call RTLO, basically right to left override. And it's basically a unique Unicode string that allows the attackers to spoof the extension of the embedded object inside a file. Basically, what they can do is to take a string, enable this special Unicode string, which is in this case U202E, provide a second string, and what will happen is that it will reverse the string and will write not the real extension of the file. So in this case, we have an HTA file that the attacker wrote as a PNG file. And with that, we can basically spoof the file that is writing to the disk and maybe, confuse the defender that's investigating the incident. So we need to keep that in mind. And the last one, which is something that we also saw really heavily in Microsoft Office documents and macros, and also now at OneNote, is the ability to formatting the documents to trick the user in a social engineering way in order to open them. For example, we have here a OneNote malware from Qbot affiliates campaign, which basically asking the user to click on the bottom open bottom in order to execute the embedded object. Really simple pictures that give the attackers the ability to confuse the users. Now I want to speak about some intelligent numbers, some words about the trends that we saw in the wild. Because if you remember, in all of these short presentations so far, I spoke heavily about OneNote as a trend. And what we need to understand is that it is a trend. It is something that is not just a short period of time utilization, but a long trend that we see massively hitting the organizations in the last couple of months. What we basically saw is that in the end of December, there was we start to see an increase, a rise in the utilization of OneNote campaigns targeting organizations, which was explode in the late January and in February to over 1,300 campaigns targeting organizations. In the left picture, we can see a really famous thread groups that associated with this activity, starting from Qbot, which saw massively around February and mid of January, async rat, which is another really common rat that's sold in the underground forums, Agent Tesla, which saw really small amount of it, and in one of the threat actors that always utilizing OneNote. They are not part of the trend, but they doing it for a few years now. And all of those numbers give us the ability to understand that threat actors start to share tools that allows them to abuse OneNote in a simple and effective way. Okay, so now I want us to start to deep dive into the malware and understand a bit more about how it works. So in order to understand how it works, we need to start with the MS1 structure, which is basically the file format of OneNote. A really important note to take here is that the MS1 store format is different from the known Office formats. So it's different from only and OXMLs, which is the old versions of Office documents, Excel, Word, and in this case, OneNote have a completely different file format, which is really interesting, by the way, because it tells us that all of the tools that we use in the past in order to investigate those macros, for example, OliVBA and all of the known tools, are not really effective for investigating OneNote. It's completely different file structure. OneNote is actually supported by two main extensions. One is .1 and one is .1talk2, which is the main two supported extension in the MS OneStore format. We will see the difference between them in a minute. And the last thing is actually the structure itself, which can be viewed in the right picture. Basically, we won't dive into each of those headers, but we need to take a note that the root file node list has all of the user data inside, which means that it have the text of the notebook, the embedded objects, the pictures, and anything that related and relevant to our investigation. Now, I want us to have a quick comparison between the .1 and the .1talk2 formats. So basically, .1talk2 is a notebook type, which means that it's basically built from different sections. A section is basically a note that can be taken inside the OneNote applications, and the section is the notebook is composed from different sections, basically. So when we're investigating one file and OneTalk2 file, we need to take it into consideration. Another interesting thing to note here is that those two file formats, those two file extensions have a different magic bytes. So we have the E4 ending with D3 for the .1, and the A1 end with 5F to the OneTalk2. Okay, so you remember that at the end of the presentation, I spoke about the actor's ability to embed an external file, embed basically an embedded objects inside a OneNote, which is also the ability of them to execute code with the OneNote file. Now I want us to take a look about how it actually works. So basically, Microsoft allows us to embed those files with a structure that named file data store object. This structure gives us the ability to insert external files. Again, external files are equal to embedded objects. This is the technical name. And with that, give the actors the ability to execute code. Now, the data store object can be identified with a special GUID, which started with E7 and end with AC, and followed with the size of the file afterwards. So here we can see basically an embedded object. It starts with the magic bytes of the data store object, and afterwards the size of the file, which is 08CD, basically a hex representation of the bytes size of the file. And afterwards, in the purple lines here, the file itself. You can see, for example, an HTML file. So this is how attackers can insert malicious embedded object inside the OneNote, which they can be abused afterwards. Okay, so now I want us to take a look on a live analysis, basically see an example of a malicious OneNote malware, and I'm sure that a lot of the theoretical concepts that we saw in the previous slides will make much more sense now after seeing that video. So before we move on to the video itself, I want to give a few words about the tools that we are going to use. So really simple tools that I'm sure that some of you maybe already know. The first one is HXD, which is basically a hex editor. Basically give us the ability to see the file in hexadecimal format. we will use that in order to extract embedded object from the OneNote file, from the malicious OneNote file. The second one will be the process monitor, which is basically known as Procmon, and will give us the ability to monitor for file disk operations inside, that the process is making. And the last one is Process Explorer, which will give us the ability to monitor for process operation, basically child processes and parent processes and the relation between those processes that the OneNote process might do. And this will give us the ability to collect the forensic artifacts that we will use later for our threat hunting session. Okay, so now I want us to take a look here, and I will, for a minute, give us a bit better quality, so we will have a good time here. Okay, so as I said, we'll investigate this OneNote malware. This is basically OneNote that related to QBot-less campaigns. So it's a real sample of QBot affiliates malware. I want to quickly open it to show to you guys how it looks like. So as you can see, this is basically the OneNote. We can see here the section name of the OneNote. So it's .1 section file. We can see here the social engineering image. And most importantly, the embedded object that the attackers try to hide behind the open button. Basically, this is an HTA file, which can contain, obviously, as you know, JavaScript and malicious scripts to execute code on the machine. Now I want us to close it for a minute and take a look how we can extract this file, how we can take this file out and be able to further investigate it. So I will open XHD and I will move the file to HXD in order to see it in a bytes representation. Now, the first thing that we can see is that the first 16 bytes are basically the header of the .1 format, as we saw in the presentation. And it's basically telling us that this is a OneNote file. Now, what I want to do is to take a look for the GUID of the embedded object, which is starting with E716, as we saw in the previous slide. And we see that we landed in an object. The next thing after the header is the size of the file, which is 5B4F, 20 bytes of padding, and the start of the file is FFD8. This is the file. This is the external file. Now, FFD8 is actually a JPEG file. So we landed on the picture that is not interesting. So we move on and look for the next one. Now, the same thing. We can see the GUID, the header, and afterwards the CD08, which is the representation of the size of the file. Now, again, 20 bytes of padding, and we are landing on PC68, which is the start of the file. Now, what I will do is to take a length with the size of the file, which is 08 CD, basically, and with that copy all the content of the file. As you can see here, I just copied it, and I will take it to a new file. So I will be able to save it. Now we know it's actually an HTA file, so I will save it as mail.hta. And we can see that we extracted the embedded object from the OneNote. Now let's take a look inside and see what we have. I will open it with Notebook++, and we can see that something fishy is going on here. We can see a variable with an obfuscated string. We will not decode it right now. Don't worry about it. We are limited in time. But what I want us to take a look is the JavaScript and the VBScript executions, and specifically these functions. This function that takes as a parameter the C2 of the attacker, as we can see, 495084, and a .dat file, which is not really a .dat file. We'll see in a minute why. And basically we'll use it for their post-exploitation techniques. Okay, it was enough, and now I want us to take a dynamic execution of the file and see what's going on. So I will start with Process Explorer. We basically use Process Explorer, as I said, to monitor for process execution in the system, to see what are the processes that are running, and we'll use it to monitor for the child processes of OneNote. The second one is ProcMon, the process monitor, which we'll be using to look for the file operations that the OneNote will do. Just make sure that you use the filter to look for only the OneNote execution events, because we do not want to see all the events, right? Only those that the OneNote is doing. Now I'll go ahead and open the OneNote. And let's see that we have all set. So we will enable the auditing. And the next thing that I want to do before the execution of the malicious object is to take a look again in the Process Explorer and try to find the OneNote process. So we'll know what actually we want to monitor, right? So as we can see, here we go. We can see the OneNote process. This is our legitimate OneNote application process. Please don't confuse with OneNote M process. It's not the host process of OneNote, it's the quick launcher. And interestingly, we can see that the target file parameter of the OneNote process is actually the name of the section file, right? The name of the invoice file. This is really helpful because it will help us in further in the hunting. Now I want us to start with the fun part. Let's execute the malware. Let's see what it does. So I will go ahead and click on the embedded object. I will click on OK. And as we can see, the OneNote is actually executing MSHTA executable. And we'll see in a minute what it does. And we can see that the MSHTA executed a CURL process that is doing something on. Let's click on it to save it. And the last thing is actually a run DLL command that was executed and actually failed. We will understand in a minute why it failed, but it also ran under the MSHTA execution. Let's open it up too, so we'll have a reference. And now let's go back and start to understand what happened. So the first thing that was executed is the most important stuff is the MSHTA. So the MSHTA was getting as a file parameter the OpenHTA file. This is the file that was inside the OneNote, right? You remember the OpenHTA? This is exactly it. Interestingly, the file is located in a weird path, what looks like a temp directory of OneNote. And in this second, I still do not understand why it's actually executing for this path. It's actually a weird path. Now let's look on the CURL command. The CURL command is downloading a file named index.png from a URL which is the C2 of the attacker, as we saw in the HTA script before. Basically, all it does is to download it and save it as index.png. Now, the reason that he's doing it is here on the run DLL. What it's basically do is to take the index1.png that was downloaded and executing using run DLL. Now I want us to get back to the MSHTA and understand what is this path, because this file shouldn't be located in this path, right? This is a weird path. I do not understand where it came from. So what I will do is to go back to the ProcMon and go to the start of the execution and start to see where this directory and this file was created. I will go ahead and look for OpenHTA. Okay, interesting. So basically now we can see that this file was created before the execution of the MSHTA. So this file was created in the temporary path before the execution was started. What it's telling us is that basically when an embedded object executed in OneNote, it will first write it to this path and then executing it. The next thing that we can see is basically the zone identifier stream, which basically telling us that this file was downloaded from an external source, from the internet. And it's another really strong indicator that we can use and leverage for threat hunting. Okay. So we basically learned a lot here, and I want us to do a quick recap on those things because I know it was pretty fast, and obviously we are limited in time in terms of the level of explanation we can give. So basically what we do now is to go over those forensic artifacts. So the first artifacts is basically really simple. We understood that the OneNote host process, the OneNote is the host process for the OneNote application, right? This is the process that will run when the OneNote open a new section or a new notebook. The second thing is that the notebook name or the notebook section, the file name that will open is the target file parameter of the OneNote process. So for example, here we can see the invoice 131223, which is the malicious OneNote file, is the target file parameter of the OneNote. The second artifact is that before an embedded object is executed, it will be written to these directories. Now, this is really important because it's basically telling us and help us identify what are embedded objects and what are just scripts that may be part of a policy. And we will see the difference between those when we will use and utilize the threat hunting notebook in the next section. But this is very important piece of artifact forensic information, and we should keep that in mind. The next one is, again, pretty trivial stuff, but it's really important, is that OneNote shouldn't execute an unusual child process, right? It's not really common to see that OneNote will execute a W script or MSHTA execution, basically. We will also see that in the OneNote notebook session threat hunting that we'll do in a minute. The next thing is really important for threat hunting is that execution of lol beans under the OneNote process that will be with a target file parameter from this path, from this temporary path, telling us that the execution was on an embedded object, right? If you will, for example, see that MSHTA run a script from a local share from any other source, which is not this path, in telling us that it's not an embedded object, it's not an external file inside a OneNote. And the last one is the zone identifier, which is not relevant only for OneNote, it's basically relevant to any file that is written in Windows, which is telling us as a stream what are if the file was downloaded from an external source, downloaded from the internet. And sometimes it can be really helpful for forensic investigation and incident investigation. Okay, I think that after 35 minutes of research, we are capable of start threat hunting. start developing our threat hunting hypothesis, and I want us to do it together. So we will going to the threat hunting notebook now, to the featured hunters, and start doing it together. So basically what we will do now is to go to the notebooks, and we will start. Okay, so a few words before we get started. So this notebook is notebook that I built inside the notebooks feature for this webinar. And I want us to take all of the relevant research findings that we gained in the previous slides and start to apply it here, right? Like we saw in the methodology at the beginning of the presentation. Basically, ideate threat hunting thesis with that research information. Now, the way that we are doing that is with phases. So we will start with some threat hunting hypotheses. We will build a query, analyze the results, and improve the query with analyzing the results. So the first hypothesis will be a OneNote parent-child process BOI anomaly. So we actually learned that OneNote should not execute other processes which are considered as living off the land binaries, right? Binaries that can be abused easily. So we can start easy, right? We can start with looking in the investigation EDR process creation and look for initiating process of OneNote, which again, this is the host process of the OneNote application, and malicious, or actually not malicious, but living off the land binaries that can be abused, right? This looks pretty simple, and it really is. The only small addition that I put here is basically a regex that what it does is to look for the embedded, that if the target file parameter was an embedded object, it will extract it from the command line. Now I want us to execute it and actually see the results together. Okay, so we have a couple of results that I want us to review and understand further. We can see we have results from multiply AIDs and also from multiply binaries. So we can see we have a W script executions and MSHTA execution. Now I want us to start to take a look on the command lines of those living off the land binaries. So the first one looked pretty odd, right? It looks like a W script execution that again happened under the OneNote process execution. This is our thesis up to this minute, and execute a VB script from the DC01 share, from the netlogon share, which is a public share. Now, unless it looks odd, and unless the W script shouldn't be executed under the OneNote application, we know something, right? We know that if an embedded object is executing under the OneNote process, it won't be in the regular path, it will be from the temporary folder of OneNote, right? And in this case, we are executing straight from the netlogon folder. Compare and contrast to this command line, which we can see that the OpenHTA file was executed from this path, from the OneNote path. So basically what it's telling us, and I'm kind of getting into the point here, is that this is just part of a policy. We just configure a policy in Office that says that when a user opens a OneNote, it will execute this Axon infra logon VBS. But it doesn't mean it is malicious, because again, it wasn't run from the OneNote object itself. It just ran as part of a policy. And this is an amazing way to identify those false positive and also to investigate alerts, right? So after building this understanding, we can go to the second phase and actually explain and improve the logic of the query, right? So what I will basically do is to take the problematic lol beans, right? The run DLL, the MSHTA, and the W script, and put a condition that say that I only want to take a look for process execution that come from this path, from this temporary OneNote path. That means that the file was an embedded object, right? So I want us to run it together again. And what we see here is that we do not get the false positive W script execution, right? Because the W script execution wasn't from this path, this problematic path. So with starting with initial thesis and improving it with the data analysis, we can improve the query and actually getting more reliable results. Now I have a little extra, and I want us to think together about it for a minute. And this is also something that we personally at Axon doing all the time. And it's really a big recommendation that I give for threat hunters, which is always look for gaps. And this is always what we do. So we are looking on the previous query that we did and start to think, what are the possibility of missing? What we could miss here? And basically the answer is with different binaries, right? So we have the target file binaries list that we conducted over the years with all of the most known living of the land binaries. But if you think about it for a minute, there is still chances that threat actors start utilizing new living of the land binaries that we maybe do not know, right? It makes sense. It's like a mouse and cat competition. And with this understanding and understanding the gap, I can having a complement query that can find those gaps. So let me explain what I did here. So I basically query again the EDR process creation events, looking for a OneNote execution, initiating process of OneNote, but instead of looking only for the target process binaries list here that I did last time, the only thing that I'm looking for is for files that were executed from the target embedded object path. And with that, we can basically find binaries that maybe execute embedded objects, but from different target file list. Maybe binaries that we missed during the creation of the query. So I want us to run it for a minute. And let's look on the result. Okay, that's nice. And now we can see basically that we have two execution of a binary that we missed on the previous query, right? You see how this approach of looking for gaps is really helpful here, right? So what we can see here is a binary named HHExe, which executed an embedded object of CHM. Now I want us to take a look about it for a minute. I won't dive and speak a lot about it, but basically HHExe, it's another living of the land binary, which wasn't unknown by QBot until the next couple of days. And this is actually a true positive campaign that we started to see in the last few days, which basically giving the ability of the actor to execute a malicious CHM files, which are basically a compiled HTML pages. Again, we won't dive into it because we are limited in time. But this approach helped us to find gaps from the previous query by asking ourselves the question of what is actually the gap, right? Okay, let's move on. So now I want us to move to the next hypothesis, to the next thesis. And in the first one, what we did is to look for a malicious execution, right? For OneNote process that did malicious thing. But I want us to take a think here and look for other possibility for threat hunting. And basically what we can do is some interesting cross-correlation queries, right? Because those logics help us understand where an embedded object was executed for malicious activity. But there are still possibility for employees to open OneNote attachment from the mail, phishing OneNote attachments, without execute the objects, right? For a variety of reasons. For example, just exit the OneNote notebook without opening and executing the file, the external file. So with that, what I want us to take a look is to find users that open attachments that originated from the mail without necessarily executing the embedded object. And with that, what we can do is, from awareness perspective, reaching to those people and ask them to not do this activity again, right? So what I will do here, I will start with looking in my proof point data source for delivered mails with the extension of .1 attachment. Now you see that I already ran it. And basically we can see here one email of invoice MasterCard Fab that was sent to my Axon Corporation mail, Honeypot Axon Corporation mail, a few days ago. This is an example for a malicious OneNote mail. Now, the next thing that we want to do is to look for the OneNote process execution and be able to extract the target file parameter of the OneNote execution from the command line. So we will be able to further compare them and find real executions. So basically what I will do is to again take a look in the EDR process creation events, look for a target process of OneNote execution, and extract from the command line the OneNote file parameter as we learned in the previous slide. So here, for example, we have our execution of the invoice .1 notebook section. And using the regex, I was extracting the OneNote file name, right? So now we have the two queries for our recipe, but we need to find a way to combine them together. So basically what we did is to create the first query as a subquery, getting the attachment file names, and then looking for executions with file attachments from the EDR process creation events. So just to wrap it up, because it can be confused for maybe some of our audience, what we basically do is to look for delivered mails in the inbox and correlate them with process execution with the same name, with the same attachment name. So basically, let's run it for a minute. I made a mistake and yeah. And as you can see, we actually could find results, and we could find execution of this malicious OneNote on the machine that we have an EDR on. Now, all of this query again isn't necessarily mean that the user executed the embedded object, but it simply means that it was opening the malicious mail, which is again something that we are interested on in order to contact the users and let them know to not doing it further. Okay. And the last query that I want us to take a look is actually related specifically for QBot characteristics, and I will explain. Basically, with investigating dozens of samples of QBot, we could find a really unique identifier for their infrastructure. Basically, the file that they were downloading will be 5 to 6 integers ending up with .dat, like we saw in the video that we explained earlier. And what we will basically do is to look in the proxy data. For example, here I have Zscaler, and looking for downloading of this type of file pattern, name convention pattern, in order to find downloads of the Qbot loader. I will say that the reason that I so love this approach is that because it can also find results of machines that do not have EDR, right? Because if an organization have a proxy that getting the results, the artifacts from all the machines, but not necessarily have EDR on all of them, he can find indication of the threat without an EDR being installed. And now let's run it and see the results. Okay, so we basically can see that we have a hit that happened on the 17th when we did our testing with CURL user agent to this IP downloading the .dat malicious loader of Qbot, as we could find. And again, this query can be executed on your proxy data and not necessarily only rely on EDR telemetry that may be missing on hosts that were affected. Okay, guys, so I will wrap up the threat hunting exercise for now. And let us know if you have any questions. I will just make a statement that all of those queries will be shared with you after the session, so you can play with them and also ask our questions further. So let's continue with the workshop. So the next thing that I want to show you,
Jonathan, sorry, excuse me, just popping in. Probably got about 3 to 5 minutes before we need to go into the question and answer.
Yeah, thanks for the note. I will go really quick on the story investigation, correlated story that we correlated automatically at Hunters for this activity, so you can understand really quick how it looks like. This is an example of a correlated query for a Qbot campaign utilizing OneNote. As you can see, all of those leads correlated together to a single story. And I want to go you through some really common artifacts and detectors that we have for this activity, because we are getting a lot of questions for customers about how you detect this activity and if you're aware to the trend. So I think it can be really a good answer for those. Basically, the first detector is the commonly abused binary execution OneNote application, which basically monitor for suspicious OneNote executions. And as can be seen, it always have a scoring model that know to increase the score for the OneNote exported temp folder, because it is an indicator of an embedded object inside the notebook. Now, further, we can see that it can also be correlated to other related activity, such the suspicious HTA file execution, which is for suspicious HTA execution under the MSHTA binary, and also other small threat hunting indicators, like the program data detector that can detect suspicious execution of LOL beans under this path. Now, the reason that I really wanted to show this story is, again, answer those questions of a worried customers about our ability to respond to this trend. So we have a lot of detectors against it, and we constantly improving it and monitor the threat landscape. So just wanted to show that as part of the workshop. And I will just wrap it up with really short remediation practices. So the first one will be consider blocking .1 and .1talk2 file extension in your email gateway. There is no way to allow it. It's not like a regular Office documents like Excel and Word that is hard to block. It's actually really, really simple because there is no reason to send OneNote attachments in the mail. It can also be shared in the cloud. There is no reason to do that. So feel free to consider blocking them in the email gateway. The second one is to consider having an EDR prevention policy for a suspicious OneNote exe with a child process of lolbin and a target file parameter from the exported temp path, like we saw over the presentation. And for those who want to take it into the extreme, you can consider disabling the OneNote embedded object feature with this specific registry configuration in this registry path and with the value of disable embedded identifiers, and basically eliminate execution of external files inside the OneNote. So I will wrap it up. We are limited in time, but I was having so much good time, guys. I hope that you had a good time and learned something. So thank you, and feel free to raise with us any questions that you have. So thank you again.
Awesome, thank you, Jonathan. There are a couple of questions here in the Q&A. First question, can OneNote alternatives be also used to deploy malware in similar ways, e.g. Evernote or Google Workspace?
Sorry, could you please repeat it? I was missing a question.
Sure, absolutely. Can the OneNote alternatives also be used to deploy malware in similar way? So options like Evernote or different options within Google Workspace. Have we seen any embedded malware in those types of note sharing applications as well?
Yeah, so it's a good question. We didn't see any trend that did something like that in the previous months, but we're keeping, monitor the threat landscape for those things. But up until now, we didn't see something like a live threat that is doing that. But maybe the possibilities exist, but still nothing that we saw practically in the wild.
Perfect. And kind of piggybacking off of that one, when or in which way did you realize that you needed to hunt for OneNote threats? How could we do something similar in unknown campaigns different than OneNote?
Yeah, this is really, really good question, and it's related to Axon initiatives and our goal. Basically, what we do is to monitor the threat landscape. We are using cyber intelligence to keep and tracking those trends. And when we see there is a huge trend in the way that transmit malware, as in this example, OneNote, we simply kicking in and started to expand our methods against it, start to perform threat hunting campaigns, started to develop new analytics to the product, such as those that we saw in the story. So just to wrap it up, we are monitoring the threat intelligence landscape and monitor for trend malware campaigns in order to come against them.
Perfect. And again, kind of staying on that similar topic, which APTs are suspected of using this current method?
Yes, so I saw a couple of them in the intelligence slide, but basically we saw a lot of QBot affiliates starting utilizing this OneNote. We also see utilization of async Agent Tesla, which using it for years. And wasn't part of the trend, but actually using OneNote. But yeah, I will just say that the ability of threat actor to share tools that are doing it is really increased these trends. So it's not only about one APT, it's about a trend and a lot of APTs that currently using it. So we need to know how to investigate it. We need to know how it works. And let's hope that it won't need to have a live incidents here on our customers.
Awesome. So that pretty much wraps up the session for today. Rashid, I know that you asked a question about getting access to the hunting queries. We're still kind of working out the details of that, but we do have access to all of the attendees that were here today. If you would like access to those threat hunting queries, please feel free to reach out, Rashid. I'll make sure I'll get those to you in one form or another. And again, thank you, everybody. The presentation will be shared after the webinar shortly. And also, please be aware that you'll be receiving a short Zoom survey after the webinar. Please feel free to fill that out. And again, thank you very much, and hope everybody has a wonderful rest of their day.
Thank you so much, guys. And we would love to hear your feedbacks and any ideas for further webinars by Axon. So feel free to raise with us a ticket or send us emails. We would love to hear your feedbacks about this session, positive or negative. It will really help us with our considerations further about future sessions. So again, thank you, guys, and see you soon.